Okay guys, today we're going to do a calculus problem from chapter 4. We're doing number 37, where we're finding the area of this shaded region in this triangular shape. So we're going to find this through integration, find this area of the shape through integration by applying the fundamental theorem of calculus we see here. And then we're going to use the power rule for integration to evaluate that integral. So first off, the area of this shape is going to equal the integral from the limits of integration on the x-axis, all right, which goes from -4 to the origin, which is 0 for x. So we go from -4 up to 0. We then have our function, which is 2x plus 8 dx, which tells us we're integrating with respect to x in this case. So we're going to integrate this. Power rule for x tells us this is x to the 1. So this would be x to the 1 right here. Power rule when n is 1 would tell us this would become x to the 2 divided by 2. So this becomes 2x squared divided by 2. This 2 is multiplied right here. Plus, now for 8, the integral of 8 dx is simply 8 times x. When we have a constant integrated with respect to x, we get that constant multiplied by x. Alright, and these are still within our bounds, our limits of integration, from -4 to 0. So now we apply fundamental theorem of calculus, where we apply these limits of integration, a and b, and substitute them into the function that we just integrated and got. So in this case, we're going to substitute in 0 and -4, so we have, this would cancel, this would just be x squared. So this becomes, now in our first part, 0 squared plus 8 times 0. Okay? Minus is minus f of a, so we plug in the lower limit of integration. So we have, in brackets, -4 in parentheses squared, and then it's plus 8 times that -4 again. So plus 8 times -4. Okay, this first part is simply 0. So the area is going to equal 0 plus 0. We can just round this off to just 0 itself. And here we still have our negatives. Keep our negative out here, and we have -4 in parentheses squared is positive 16, plus 4 times plus 8 times -4, which would be minus 32. 16 minus 32 is -16. So that's negative on the outside, -16. So the answer ends up being positive 16. So the area under this curve is positive 16. And then we can check this by using our area formula for a triangle. Okay, so we have area of a triangle is equal to 1/2 base times height. We're going to put an absolute value around this because area is always going to be positive for this formula. And we get 1/2 base, which is 0 to -4. That distance is 4. Right? We're using our absolute value to get a positive 4 for this distance, 4, and then 0 to 8. Okay, that would be our distance from the origin up to this point on where it intersects the function. So that's 1/2 times 32, which is also 16. Okay, so we can see here that this answer through integration checks out and is the same as for just a regular area of a regular triangle. Okay, so this check looks good for both.